Alright everybody, so here's our three scatter plots for number 2. We had one that looks something like this, very close, tight dots going in a positive direction. We had one that was kind of all over the place, and one that was still positive, but a little bit more scattered out. So something like that. And so our three scenarios were like this. We had each of them dealt with these 34 physically active men. For the x value was their height and the y value was their weight. For B, the x was their waist circumference, so if you could measure, like with a tape measure, around their waist. And then y was the belt size, like so what size belt that person would have to wear. And then the last one was their age. X was their age, and then Y was their foot size. So how big each guy's foot was. So let's look at each one of these kind of together. So A, the height versus the weight. We've seen already kind of that like the taller a person is, the more they tend to weigh. We saw that already in 3-2, that a higher person, there's just more person, there's more mass to the person, so they're probably going to weigh more. So I would expect to see a positive relationship here. As the people's heights are increasing, their weights are also increasing. So I'm going to just kind of make a little note here and say that I know that this one is going to be positive. I know that's going to be positive. So it's going to go up in that direction. The waist circumference and the belt size. Well, I thought about this one, and the waist circumference is the inches around your waist. The belt size is what the number we give to the belt. I mean, it's very similar to the size of men's pants. I know ladies' pants have a different kind of numbering system, but men's pants, the number is pretty close to the number of inches around your waist. So these things are also going to be positive. As you have a bigger waist, you have a bigger belt size. So I'm going to say that this is probably also going to be, I'm fairly confident that's also going to be positive. And then this age and foot size, I thought about this one for a second, and if you have a certain foot size when you're 20, that foot size probably isn't going to change very much when you're 60. So whatever your foot size is, that's just what the size is. Your age doesn't really mean anything for that. Your age could be, you could be a 30-year-old person or a 50-year-old person, and your foot size would probably remain the same. It wouldn't really change from one to the other. As you get older, at some point, everything kind of stops growing, and I think that your age and your foot size, there may not be that strong of a relationship there. So over here, it's not really positive, it's not really negative either. As you get older, your foot doesn't get smaller. I mean, maybe a little bit, but not significantly smaller. So I'm not really sure. I'm just gonna say that there's no trend. No trend or no relationship is another way to say that. So let's go back and look at our scatter plots and see what matches up. A and B, the height and weight and waist and belt size, we said that both of those were pretty much positive. And we have two positive ones. 1 and 3 are both positive. But it looks like 1 is if we were to draw a line in the middle of this thing, 1 is very close to that line. 3 might be a little bit more scattered around that line. So it looks like the question becomes now, which one is a stronger relationship? The height and weight, or the waist circumference and the belt size. And this one is kind of there's a little bit of logic. We got to think about this. We got to think for a second, well, which one is more closely related to the other? So if I knew the height of a person, how closely could I guess their weight? If I knew their waist circumference of a person, how closely could I guess their belt size? And I think that this one, the waist circumference and belt size, is probably a stronger relationship, because your waist circumference and your belt size, like I was saying before, that's pretty much how they decide what the belt size is. If your waist is a certain inches, well, that's the size of belt you wear. There's not much playing around with that. So if you have a 36-inch waist, you get a size 36 or size 38 belt. That's just kind of how that works. And so it's very close. If your waist increases by 1 inch, your belt size would increase by 1 number. probably, or one or two numbers. And so I think that's a very, very strong relationship. If someone told me the waist circumference of a person, I could very, very closely predict what their belt size was. So I'm guessing a very strong relationship going on right here. So I'm going to call this one B is number 1. So number 1, I'm going to say is B, because it's a positive relationship, and it's a very strong relationship. Now, height and weight, it also works. As you get taller, you also weigh more, but I don't think it's as, cause and effect as like, well, even though this one isn't really cause and effect either. I mean, technically we can't say it's cause and effect, but for this one, it's not exactly one is making the other one happen. Because you can have a very tall person who doesn't weigh that much. You could have a very short person that weighs a little more, but not so much flexibility in the weight, in the waist size and belt, in the waist and the belt size. If you have that size waist, you have to get that size belt. Not so much the case of if you are this tall, you have to weigh this much. So I think there's a little bit more gray area in this scenario. So I'm going to say this one is A. And we only have one left, So I think we're safe to say that C is number 2 right here. And that kind of makes sense because as your age, this is your age down here, as the age is increasing, foot size, it can do whatever it wants to do. There's not really a way to predict that. If I told you that here's a 40-year-old guy, what's his foot size? There's not really any information. You can't really figure that out with anything. So that makes sense to me. That C would be this kind of one that's all over the place. Now they ask us one last thing is what does each dot represent in each of the scatter plots? Well, A we said was number 3, and that was our height and weight of each of these men. One dot on this one, well, each dot represents one man, and each man is and the way it's put on here is based on their height and their weight. So each dot represents one man. So each dot is one man. Waist circumference and belt size for B, that was number 1. Same thing. Each dot represents one man. For each man, we measured 2 things. We measured his waist size and his belt size, but there's still each dot represents one man, one of the 34 active men. And then C, same exact thing. Each dot was one man that we measured their age and their foot size. So one man. All right. So hopefully the logic we looked at in this one can kind of help out with the next exercise has 6 of these that we have to match up, and not all of them are straight lines either. Some of them are kind of curved a little bit. So give that a shot. Hopefully that works out pretty good, and hopefully you get some good kind of back and forth about which one should be which. And I'll be curious to hear kind of what we had to say about that when I get back. All right, guys. So good luck on the next one, and I'll see you here in a minute.